In previous class we have seen one way of code reuse through composition. Now let us see second way. Through inheritance also we can reuse the code. Let us see what is inheritance. Inheritance is a fundamental concept of object-oriented programming. Inheritance is a mechanism of deriving a new class from another existing class. The class that does the inheriting is called subclass. The class that is inherited is called superclass. An object created through inheritance, are also called as subclass object, acquires all the properties and behaviors of superclass object. But constructors will not be inherited. Subclass inherits all the members defined by superclass and adds its own unique members. In Java, inheritance is used for code reuse and to establish subtype relationships, also called as user relationships. Today let us see first use of inheritance, code reuse. In Java, to inherit a class we can use the extends keyword. This is the general form of class declaration that inherits superclass. Let us take simple example. Create new Java project, inheritance. Delete this module info.java. Take one class A. Assume that it has two properties I and j. Let us write constructor. Initial values are 10 and 20. And take one method m1. It prints I and j values. Let us create new class by extending class A. Assume it has one property k. Constructor initialize k value to 30. This class B has method m2. It prints its property value k. This class B is extending class A, so class A property is also directly accessible here, means this I and j can also be accessed here directly. So let us print those two also. Let's take one more method sum. To this subclass method sum and m2, all the superclass members directly available. So this I and j can be directly used here without using object reference, as they were part of this class B. This B is extending class A, so this is the subclass. This class A is extended by class B, so this is the superclass. Let us take another class, inheritance demo, with main method. Include this main method stub. Create the object of class B. Here, this subclass object acquires all the properties and behaviors of superclass A in addition to its members. Means it will have its member k and these two methods m2 and sum. In addition to these three, it will acquire all these properties I, j and this method m1. For this subclass object, all the members of A are available. To understand this, let's take object layout. With respect to inheritance, chain of objects will be created in association with each other. This class B object and this class A object both will be created. This superclass object has these fields I and j and one method m1. We can access this superclass fields I and j with this subclass object reference B. With this subclass reference B, we can access this m1 method also. With B reference, we can access I, j and k. So let us check. Let us reassign its value to 100. With the inheritance, this superclass object members available to this subclass object. So with this subclass reference, we can access these two methods sum m2 as well as this m1 method from the superclass. So let us call the all three methods. Let us run this program. This m1 method is printing I and j values. Initially ij values were 10 and 20. In this main method we reset these values to 100 to 100. So we got this output 100 and 200 for I and j. Then we are calling this m2 method, which is printing I, j and k values. So we got this output. Then this method sum is printing sum of I, j and k values. So it is 600. In order to create object of any class, creating its superclass object is mandatory. Always these superclass objects are created from the subclass constructor. Here B is the subclass, so before creating the subclass object, its superclass object will be created. Every class in Java implicitly extends the object class. So one more object will be created of object class. Always superclass objects will be created first, then only subclass objects will be created. To verify that, we can add one statement in the constructor. Let us rerun this program. See here, A's constructor is executed first, then B's constructor is executed. So from this we can conclude that first superclass object will be created, then subclass objects will be created. Even though this A class is the superclass of this class B, this class A is completely independent of class B. Being a superclass for a subclass doesn't mean that the superclass cannot be used by itself. So we can create superclass object also. With this superclass reference A, we can access all the members of superclass. We can access this I value with this superclass object reference A. We can access superclass method m1 also. Let us run it again. When this statement executed, A's object is created. Here A's constructor is executed. We are resetting I and j values to 500 and 600. After that we are calling this method m1, which is printing this I and j values. So this method is printing I value 500 and j value 600. With this superclass object reference A, we can access only superclass members. We cannot access subclass members. If we try to access the subclass members K with this superclass reference A, it will raise error. K cannot be resolved. But reverse is possible. With the subclass object reference, we can access the superclass members I and J. B object can be assigned to this superclass object reference. We created superclass object reference which is of type A, which is pointing to this subclass object B. But here this reference is of type A, so it can access only superclass members. With this reference we cannot access this subclass members. Even it is pointing to this subclass object. Let us check that. It will give you the error. The method m2 is undefined for type A. But with this reference we can access method 1. It is allowed. In this superclass, for these fields we did not use any access specifier, so it would be default. Suppose if we use here private, then these fields will not be available to this subclass B. We'll see access specifiers in the next class.